Let's do some operations with standard number, or with complex numbers rather. Complex numbers, the standard form, remember, is A plus BI, where A is the real part and BI is the imaginary part. Okay? And so if B equals 0, then we have a real number, because you multiply 0 times the square root of I and you get 0. So you just have a real number. A is the only thing that's left. If if A is equal to 0, okay, A is equal to 0, and then you have a pure imaginary number. And so then we're going to find x and y, so that 2x plus 3iy is equal to negative 8 plus 10i. So x and y are equal to what? Well, this is really simple. It's all you have to do is make this part and this part equal, and this part and this part equal. So 2x is equal to negative 8. You divide both sides by 2 and you get x equal to a negative 4. So that's equal to a negative 4. Y, you got 3iy equals 10y. Or excuse me, 10i. My bad. I am new at this. Take it easy on me. So 10i. Okay. So you divide by 3i, and you have y all by itself on the left, and i's cancel, and so you get 10 over 3 for y. So y is equal to 10 over 3. So that's a real simple way of finding, this is what x and y will equal, so that this is a true statement. Okay? Sorry about the scribbling. Let's try something a little bit easier here. How about we add complex numbers? So add complex numbers goes like this. Negative 3 plus 5i plus 7 minus 6i. Well, let's see. Negative 3 plus 7 is equal to 4. And 5i minus 6i is minus I. 5 minus 6 is negative 1. Negative 1 times I. So you can see the I here operates, it works just the same way as a variable would work. Even though I is a constant, it's not a variable. It doesn't change a value. The value is always going to be the same, and that's the negative square root of 1. Or square root of negative 1, I mean. And so 4 minus I. Let's try subtracting, and subtract looks like this. Negative 3 minus 8i minus negative 2 minus 9i. Well, negative 3 minus a negative 2 is a negative 3 plus 2, which is negative 1. Okay? And then negative 8y minus a negative 9y, that's negative 8i. Did I say y? I am so sorry. Negative 8i minus a negative 9i is a negative 8i plus 9i, which is plus I. And so simplifying this, it equals this. Okay, hope you're with me now. And now we're going to try something a little trickier. We're going to multiply. And we do that like this. 2 plus I times negative 5 minus 3i. Now you guys are going to see this is just exactly like, well, in fact we do. You use a FOIL method. First is 2 times negative 5. That's negative 10. The outer, 2 times negative 3i, which is negative 6i. And then the inner is I times negative 5, negative 5i. And then the last is I times a negative 3i, which is negative 3i squared. Now this is where we get a little funky here, because I squared is equal to I times I. Well, what does that equal to? That's the negative square root of 1 times, square root of negative 1 times square root of negative 1. What does that equal? Negative 1. So I squared is equal to a negative 1. So we have this is negative 1 times negative 3. And so what's a negative 3 times a negative 1? That's a positive 3, of course. And so we can simplify this. Negative 10 plus 3 is a negative 7. And then negative 6i minus 5i is a negative 11i, because 6 and 5 make 11. So this is simplified, and this is in standard form. Now, that being said, I'm going to show you a couple of neat little tricks here about I. Now, you know that I to the 1th power, well, that's just equal to I, right? Which is the square root of negative 1. Well, I to the 2th power, as we like to say, well, that's I times I, like we just said, and that's negative 1, like we talked about a moment ago. I to the 3rd power, well, that's I squared times I, isn't it? Well, I squared, we already said, was negative 1. What's a negative 1 times I? That's a negative I. And I to the 4th power equals I squared times I squared, right? I squared is equal to negative 1. So what's a negative 1 times a negative 1 equal? Positive 1. Now let's try something a little bit different here. Let's try I to the 5th. Well, that's equal to I to the 4th times I, isn't it? I think so. So I to the 4th is 1 times I equals I. What's I to the 6th power? Well, that's I to the 4th times I to the 2th equals I to the 4th is 1. I to the 2th, that's negative 1. What's 1 times a negative 1? Negative 1. I to the 7th, I to the 4th, times I to the 3rd. I to the 4th is 1. I to the 3rd is negative I. So 1 times negative I is negative I. I to the 8th, I to the 4th times I to the 4th. And that equals 1 times 1, which equals 1. But wait, there's more. What do you suppose I to the 9th, I to the 10th, I to the 11th, and I to the 12th would be? And if you said that I to the 9th is equal to I to the 10th is equal to negative 1, I to the 11th is equal to a negative I, and I to the 12th is equal to 1, you would be absolutely correct. And if you went even further and said I to the 13th, and I to the 14th, and I to the 15th, and I to the 16th would equal I and negative 1 and negative I and 1, you would be correct there as well. And as you can see, we have a pattern. So anytime, let's say you want to know what I to the 24th would be. Well, 13, 14, 15, 16, 17, 18th, 19th, 20th, 21, 22, 23, 24 would be this one right here. So I to the 24th would equal 1. What we're really interested in here is using this in our multiplication and division and squaring and things like that. So that being said, now that you understand that formula or the pattern, and like I've said many times, math is a science of patterns. The more you see the patterns, the easier math is going to be for you. So let's try some more easy stuff here. And Remember I said conjugate. Conjugate of a plus bi is a minus bi. And watch what happens here when I multiply. Oh, and it's shown a plus bi with a line over it like that. Put a line over the whole thing. There's talking about that's the conjugate of a plus bi, which is actually a minus bi. So a plus bi times a minus bi. Watch what happens when we FOIL. First, a times a squared. Outer, a times negative b. Negative a b I. Okay. Inner, bi times a times b times I. And last, bi times a negative bi. So that's a negative b squared, I squared. bi times bi, and positive times a negative. Negative bi, or b squared, I squared. So what does that end up being? Well, a squared is a squared. And these two, when you multiply any binomial by its conjugate, you eliminate these two. That's the whole idea here. And so you get minus b squared times I squared. Well, what is I squared? Negative 1. So you have a squared plus b squared. Negative 1 times negative b squared is positive b squared. So that's how this conjugate thing works. Well, what does that all mean? What's the point in all this stuff? How come you're teaching us all this silly stuff, Mr. Mishler? Well, it's because I love you and I want you to know things. And here's one of the things I want you to know how to do. 2 plus 5i over 2 minus 3i. So we want to simplify this. And here's how we do this. We multiply the top and bottom by the conjugate of the bottom. Now this is equal to 1, you know that. So I'm not changing the value of this, I'm just multiplying it by its conjugate. So 2 times 2 is 4. 10i, 5i times 2 is 10i. 2 times 3i is 6i. So 10i and 6i make plus 16i. And then 5i and 3i is plus 15, because 3 times 5 is 15. I times I is I squared. Remember, when we see an I squared, we know that that's equal to a negative 1. But let's look at the bottom. Remember I said it's equal to a squared plus b squared, but let's just work that through. 2 times 2 is 4, okay, plus 2 times 3i is 6i, minus negative 3i times 2 is 6i, okay, and negative 3i times a positive 3i is a negative 9i squared. Well, again, these two cancel, so we're done with that. And this is equal to negative 1. So on the bottom, we have 4 plus 9. On the top, we have 4 plus 16i, and I squared is negative 1. So negative 1 times 15 is minus 15. What does that simplify to? 4 minus 15 is a negative 11 plus 16i. Over 4 plus 9 is 13. Now we want to write that in standard form. Standard form is a plus bi. So we have to write it this way. Negative 11 over 13 plus 16 over 13i. Next. But wait, there's more. What about 3 minus 4i over 2 plus I? What do I multiply it by? You got it, 2 minus I, the conjugate of your denominator. Multiply the numerator and denominator by the conjugate of the denominator. That's equal to 1. And so we're not changing the values. So 2 times 3 is 6. Negative I times positive 3 is minus 3I. 2 times negative 4I is minus 8I. And then negative 4I times a negative I is a positive 4I squared. You know, we're going to simplify this in a moment. Here we have 2 times 2 is 4, minus, we can just forget about the middle stuff. We know they're going to cancel each other. So minus I squared. So every time you see I squared, change that to a negative 1. And so on the bottom, you have 4 minus a negative 1, which is 4 plus 1, which is 5. On the top, we have 6. Negative 1 times 4 is negative 4. So 6 minus 4 is 2. And then negative 3i and a negative 8i is a negative 11i. So we have 2 over 5 minus 11 over 5i. And there we are in standard form, and we're all set. And you've been very, very good watching. Thank you. Have a great day.